Okay, go. All right. So, good morning. Thank you for coming to my talk. What's a WASM? This is an introductory talk about WebAssembly. So I'll tell you what it is, how to use it. First, a little bit about me. Paul Milham, that's my name. And I work at WildWorks. This is a job I enjoy a lot, actually. So I get to work on Animal Jam, which is a really awesome game. So maybe think World of Warcraft for preteen girls. Probably not selling it for a lot of you guys, but I really enjoy this job. It's good. So a little disclaimer, I'm not a member of the WebAssembly working group. If that disappoints you, there's a better WebAssembly talk going on just down the hall. So you can head down there. But if you leave, we're no longer friends. Just remember that. Okay, but hey, you know, level 30 in Pokemon Go, or 29 and a half, but I'm close, right? So hopefully that makes up for it. And I just had a baby last month. Aww, right? Thank you. Almost a month old. He's got his daddy's hairline, so that's exciting. And here he is compiling his first WebAssembly module. If you squint, you can see that function he's working on is named poop, which seems appropriate. Okay, anyway, enough about that. So I just want to run through what we're going to or what we're going to cover in the session. So first we're going to talk about what is WebAssembly. Talk about some myths, things you might hear about WebAssembly that aren't really the actual truth. We'll talk about loading WebAssembly modules, so how you actually get it running in node.js or your browser. We'll look at some actual WebAssembly code and how to use it. Look at JavaScript interopt. So how do you talk to WebAssembly? How does WebAssembly talk to JavaScript? Some high-level use cases for WebAssembly, like when would you actually want to use this thing? And we'll look at some languages that compile to WebAssembly. So how do you actually get these WebAssembly files? Okay, so what is it? WebAssembly, or WASM, I'll use the terms interchangeably throughout the presentation, is a new portable, size and load time efficient format suitable for compilation to the web. And so this is a really good description. It's a binary format, and it's really fast, and it's a compile target. All right? So binary coded assembly, I think, is a really good word here. So if you look at WebAssembly code, don't expect anything fancy, like a for loop. Okay? You're not going to get anything like that. It's a lot lower level than that. You can't really see that. That's like WebAssembly in the matrix. You feel cool when you write WebAssembly, all right? So that's nice. It's an efficient and fast stack machine, and it's safe, open, and debuggable. In other words, it's web tech. That's great. This is not some separate thing. This upholds all the values of the web. And this is real. A lot of people don't realize this, but WebAssembly is in your browser now. It's in Firefox. It's in Chrome. It's in Safari. Not Edge yet. It's going to get there. But and Node.js. So download the latest Node. You can try it right now if you want. You could type WebAssembly in, hit enter. You're going to see there's an object there. That's cool. So it's real now. This is something you can use. So one thing I've heard a lot is WebAssembly. Okay, this is something that'll just take my JavaScript file, put it in the WebAssembly machine, I have faster JavaScript. That's not really how it works. That's not at all how it works. It's not going to make any of your JavaScript magically faster. All right. So this guy on the internet that's smarter than me said this. So the MVP version, the minimum viable product, that's what's live in WebAssembly right now. It doesn't support garbage collection or JIT capabilities, which make it possible to implement a fast JavaScript virtual machine. An interpreter is entirely possible. With clever tricks, it can be quite good, but not as much as what native implementations do. Point being, if you want to run JavaScript in WebAssembly, you'd have to write some sort of interpreter or something like that, and you can do that. But it's not going to be as fast as the native implementations out there right now, at least not until we get some of these other features. Okay, so another thing I hear a lot is just good for games. It doesn't really help that the first thing you see, well, one of the first things you see on the WebAssembly.org website is a game. It's a game demo. It's a cool one, though. You can drive tanks around and shoot each other. I'm going to throw a little disclaimer in here. If you're working on anything that isn't a game, you're kind of wasting your time. It's a known fact that computers were built to play games. So I'm a game person. But anyway, WebAssembly is being used for a lot of different stuff. Some really interesting things right now is people are experimenting building virtual DOM with it. That could be really cool. Virtual DOMs everywhere. You're hearing about that all the time, right? And so maybe we'll see that move to WebAssembly. I don't know. Another thing is you can just take these C++ libraries, and there's a lot of C++ code out there. You can take them and you can compile them to WebAssembly and efficiently run them on the web. This is one I'm really excited about. You go to web pages and it starts mining bitcoins for someone. Those are going to be so much faster now. That's cool, right? Yeah. No. Okay, that was dumb. Let's move on. Sometimes I see a lot of like JavaScript modules. It's like they're like, I don't like C++ code. I don't want a native module, so I'm just going to rewrite it in JavaScript. I hope we'll see some of those move to WebAssembly. You're going to get almost as good a speed, and it's fully portable. Work on any system, which is really cool. Another thing you might hear is that it's unsafe. So there's no garbage collector, right? You manually manage your memory in WebAssembly. And so can I have vulnerabilities, things like that? Not really. So WebAssembly, its memory is just a JavaScript array buffer. That's all it is. You can't do some arithmetic and read past the end of the array and start accessing variables that you're not supposed to have access to. It's contained. It also will be garbage collected, just like any other JavaScript object. If your module goes out of scope, it's going to be cleaned up. And so again, it's not going to be able to access like the window object by default, anything like that. So it's not going to be able to peek at your other things and cause havoc. Like you're not going to get download a malicious WebAssembly module and then it starts stealing all your data. So yeah, I already said that. Sorry. Okay. So another myth is that it's a JavaScript replacement. You don't need to feel threatened by WebAssembly or anything like that. So WebAssembly complements JavaScript. I really like this image. So it's a little bit modified JS logo, but it plugs into WebAssembly. All right. So they should complement each other. So WebAssembly is kind of like a new superpower for JavaScript. And there are some reasons why WebAssembly cannot replace JavaScript. It's impossible right now. One reason is there's no direct DOM access from WebAssembly. So you can't even replace JavaScript completely if you wanted to because you need some glue code to talk to the DOM. So how do we load a WebAssembly module? Well, you can't do this, unfortunately. That would be super cool. But what you need to do is you need to load the actual module bytes from the disk or network, and then you need to instantiate them. So that you compile them in your JavaScript code, and then you have a reference to a WebAssembly module. So what does that look like? Well, it can look like this. So we'll go ahead and fetch the module from the network. That's our module.wasm. This is a binary file that we're fetching from the network. We get a response, and then we turn that into an array buffer. So now we have bytes. Now you can use this WebAssembly object. It's just this global, call instantiate on it, and pass in the bytes. And then we get a reference to a module. So this is just JavaScript. And now we have a reference to that WebAssembly module, and we can do things with it. So WebAssembly code itself is binary. You're not going to open up these files and peek at, well, maybe you should. I don't know. Open it up and check out what's in there. But what you probably will look at is the text version. That's called WAT file, W-A-T. It used to be WAST. I thought maybe they thought WAT would be funnier. I don't know. But anyway, that's what we've got. So WAT files. I guess, yeah, hilarious, right? Okay, so anyway, so what does that look like? It looks like this. And there's a lot of information on here, so I'm just going to walk through what we see here. So this is a WebAssembly text file. And it's a very simple module. You can see the top line and the bottom line. That's just declaring the module. And comments you do with 2 semicolons. So this is just a function that adds 2 integers. That's all it's going to do. Now, this is just for demonstration purposes. Don't go home and like compile this module and be like, hey, all my addition operations are super fast now. That's not really how it works. You don't want to do super simple things in WebAssembly because there's overhead in making the call to WebAssembly. So anyway, just for demonstration purposes. So we're creating a function, we're exporting it, and its name is addy. It takes 2 parameters. The first one, I've named it first, is a 32-bit integer. The second parameter, second, is a 32-bit integer, and it returns a 32-bit integer. You can see this is really low level. There's no frills here. In fact, the only frill is that I can name my variables. Other than that, you're on your own. The comment's kind of hard to see, but we just add the first and the second, and we push it onto the stack. So you can see we have a 32-bit add operation. We get our first value, we get our second value, we push it onto the stack, and then that's returned. Okay, so really, really low level, really cool. Now, how do we declare memory? In WebAssembly, if you want to use linear memory, by default you have linear memory, and you can declare it like this, and I can even export it so JavaScript can use it. So you can see on the third line there, I'm exporting a memory called mem, and that's how I'll reference in JavaScript. And it's 8 pages. Each page is 64 kilobytes. Okay, and now I have a function at the bottom, and I just called it pokemem. I don't know, it seemed like a good function name, but all it does is it's going to store 1 byte. That's I32 store 8, so we're storing 1 byte at the beginning of the array. That's our 0, and we're storing 1. That's all this function does. It's just going to store 1 and the first byte of our memory. So, yeah, seems like a good use of all that memory. Now, WebAssembly is typed. It's strongly typed, and there are 4 types. No more, no less. 4. Okay? Nothing extravagant like a string in here. Okay? Don't even think about classes or something like that. So if you're working with the raw WebAssembly, this is what you get. You get a 32-bit integer, a 64-bit integer, a 32-bit float, and a 64-bit float. That's what you got going on. And it's a stack machine. We saw how that works a little bit. You can export functions. You have memory. And you have these low-level commands. There aren't even that many of them. You can go and get a list of them. I don't know how many. There's 60 or something like that. So how do we talk to WebAssembly? And how do we call these exported functions? We're going to run through some examples of that. How do we access memory? So this is how we do it. Again, this is our JavaScript code. This is the code that we saw at the beginning. And all it is, this is just instantiating the module. So we add a few more lines when we want to access it. So you can see we've added this exports, module.instance.exports. This has all of the things we've exported on it. So now we have references in JavaScript to these things. So we can call addy. That was our super advanced function that adds 2 integers, right? So we can call that and we get the result back. One thing I want to point out here is this is a synchronous call. So we're not awaiting it, we don't get a promise, there's no callback, nothing like this. And so all you do is synchronously call the functions you've created in WebAssembly. Add them, get the result, and you may or may not be able to see that we actually do get 3. 3 is logged out. So that's good. 1 plus 2 works. How about our poke memory function? So let's go ahead and run it. And you can see in exports.mem, that was the thing we exported. We have access to a buffer instance. Let's create a new view on that. It's a uint8 array, and if we access the first one, we can see that it is in fact 1. So that's great. We manipulated memory in WebAssembly. So now how do we talk to JavaScript? So that's pretty cool, but I mean all we can do is raw calculations with that so far. So we use imports. These are functions that can be called from WebAssembly. JavaScript functions we can call from WebAssembly. So let's take a look at that. Again, this is the same code that we saw at the very beginning, but now when we instantiate the module, we pass in an optional object. So this has an object utils with a function log, and all it does is say hello from wasm. Again, not something you probably actually want to do, but let's look at how it looks on the WebAssembly side. And you can see on the 4th line there, we have an import keyword. So we're importing that utils object with the log function, and we're calling it log. See that $sign log? Now I am adding another function, a WebAssembly function that is accessible from JavaScript because I'm exporting it called JSLoggy. And all it does is calls this log function. Okay? So this is like the most efficient way you could log something out, right? You call into WebAssembly and it calls back to JavaScript. So let's go ahead and see if it works. We call it, and you can see there, in fact, it does work. We'll see in the console, hello from wasm. This is really important. This is a useless case, like I mentioned, but this is really important because this is how you're going to access all of your web APIs from WebAssembly. So you can do a lot of cool stuff in here. You can you can do your WebGL stuff if you're doing a game, or whatever. Anything, as long as you have this JavaScript glue code, can be accessed from WebAssembly. And importantly, it cannot if you do not pass in those imports. This is another reason it's safe. So at WildWorks, we have this, this project, and it's a customer support tool, basically. They can log in, they can open up this tool, they can see what items the user has, what their avatar is wearing, all sorts of things, but it's really useful for our agent to be able to see visually the items that the avatar has in Animal Jam. And so we have this custom image format that all of these images are coded in. And I implemented a decoder in JS, and it was not fast. Now, I don't want to just blame JS in this. The code was also sloppy, okay? But it was too slow. The naive implementation was much too slow. So I spent time optimizing it, and it was still too slow. Started out ridiculously bad, like, I don't know, 40 milliseconds, 60 milliseconds or something per image. And it got a lot better, like 5 milliseconds or so, but it still wasn't fast enough. And so what about WebAssembly? Can we move this number crunching to WebAssembly and see if it's faster? So let me show you the WAT code, what this ends up actually looking like. Let's see, can you see this? Okay, so I just hand coded this, which I would not recommend. It's not that much code, but I don't know. I'm kind of a young programmer, and so all of the people that coded like entire applications in assembly probably think I'm a wimp, but I'm not sure I would go there. It's kind of painful to work in. But anyway, so this is kind of what it looks like. And what this does is it just takes our custom format and it decodes it, and then we can take these bytes and turn it into an image. Okay? And so let me show you, if the network cooperates, I'll show you what this actually looks like. So this is our customer service tool. It might explode if I upsize it. Okay, Animal Jam moderator. And let's go ahead and look up my user. Okay, great. So this is my user. I'm not like displaying someone's personal information here. So I don't think I'm actually 35 years old though. I don't know, something like that. Anyway, so this is the tool, and I can look at this user's inventory. And so pretty quick, so I can see all these items that my user has, which is really cool. I've got some cool stuff on here. I scroll, it loads. You know, before we were having like this thing freeze up as we scrolled, which was not awesome. Oh, look at that bone dolphin. That's cool. Anyway, so yeah, a lot of cool stuff in here, and it's fast. We're pretty happy with the result, so that's good. So let's go back here. So one thing that I've noticed about WASM or WebAssembly is that it seems to warm up faster than JavaScript, which is really cool. So you put stuff in and it runs fast right away. I don't know if the implementation details of this will change as it goes along. I mean, we're really just on the first phase of this stuff, so it's really already exciting. But with JavaScript, your code has to get really hot before it optimizes it. And that's not really the case here, it seems. It's just quick, which is awesome. So, okay, ChickenMark. This is the latest in benchmarking technology. I can say that because no one else has written a benchmark in the last 2 hours. So let's check this out. Hopefully you enjoy it because it's pretty much the worst way in the world to visualize any data. So let's see if it works here. Let's see. There we go. Okay. Oh, I didn't explain it. Stop, chicken. Hold on. Okay. So so we're gonna JavaScript is the yellow chicken, all right, and that can be the daddy or the mama chicken. I don't care. But WASM is going to be the other chicken, right? And so you might be like, hey, Paul, actually a male chicken's called a rooster. Well, whatever. Okay. So we've got these two chickens, and they're going to work together to gather up their baby chicks. Okay. So it's a speed comparison, but it's also a cooperative effort. Hopefully you're grabbing the deeper meaning here, right? Okay. So anyway, let's go here. Okay. So what's happening here is I have a main thread, right? and it's running the logic that tells these chickens where to go and bounces them around and renders and things like that. But I have two web workers, and they're running the same logic. Okay, one I coded in JavaScript, and the other one I wrote in C and compiled it to WebAssembly. So you can see the WebAssembly is a little bit faster, which is cool. Okay, and so that looks like a bug. Oh, anyway. So pretty much the worst way in the world to visualize data, but it's kind of fun. So JavaScript, to be fair, this is cherry-picked, right? I wanted that purple chicken to go fast. But JavaScript is actually very, very fast with simple things, and it can optimize and get super, super fast. Benchmarking is a really tricky thing to do, and it's like statistics. It's basically all lies anyway. So look at that blinky chicken. It's pretty cool. I don't know. Anyway, ChickenMark. It is available at a license. Talk to me after the session. All right. Okay. Anyway, that's your little unique treat for coming to this session. So why would you even use WebAssembly though? Well, I think anything where you're really taxing your CPU is a good candidate. I think you could use it for that. And I also think it's a great candidate just for porting legacy. We're JavaScript developers, right? Anything that's not JavaScript is legacy. So porting those things to WebAssembly is a great idea because you can just compile it and it's usable. So some examples I've seen in the wild. Someone compiled JavaScript core, which is the JavaScript VM in Safari, to WebAssembly. So that thing at the beginning of the talk, we're saying don't ever do that, it's a waste of time. Someone went ahead and did it, which is cool. It's cool that it's possible though, right? So I should have had one of those like yo dog things. You got JavaScript in your WebAssembly. I don't know, anyway. Another thing is this Pixie.js, which is a WebGL rendering library. It's a really good one too. I'd recommend checking it out. So it has an extension called CreaturePack, and they ported their 2D mesh transformations to WebGL. Saw a big performance boost there, which is really cool. So it's basically taking a bitmap and dynamically transforming it so it looks like it moves around, which is really cool. If you want to check it out, you can check it out there. The slides are online, or if you can type furiously fast, you can get in there. Okay. Again, people are looking at implementing virtual DOM with it. These are all really, really cool things. And we're just at the beginning of this. I'm really excited to see what people come up with. I saw a PR for compiling C# to WASM. I don't know how that's working, but pretty cool stuff. There's a little game called Funky Carts. So it's on Google Play and iOS App Store. But they wanted a version that could show off on the web, and so you can run this game on your mobile device. It runs great. It's just a C++ game. It renders in WebGL. It's really cool to see this stuff running fast. And if you're a game developer for a long time, the web is awesome, right? It's so awesome. But then you start dropping frames while the JavaScript garbage collector runs, and you're like, no! Okay, but this WebAssembly is what we've been looking for. It's very fast, very efficient, and you can have it run smoothly. Super cool. Okay, now why would you compile to WebAssembly instead of just writing a WAP file yourself? Well, it's pretty painful, so I would not recommend coding WAT by hand. It's low level. Again, you're not going to get any language constructs really. And it really should be looked at as a compiler target. So it's something that you're going to write code and compile to. That's how I would view it. And there are a lot of languages that compile to WASM. This is probably the most popular one, C, C++. And I think if you're serious about doing this, this is probably the first thing you should pursue. And I want to show you this WASM fiddle. It's really cool. Oh, sorry. He was taking a picture and I just turned it off. So this is really cool. So let me erase this. So I've got a super advanced function here called main, right? And I don't know why it's called main. That's a dumb name. Let's change that. Let's call it foo. That's way better. Okay. So I've got foo. It's a little hard to see, but it's just int foo and it returns 42. And let me make it a little bigger. Maybe you'll be able to see it. And then you can see the output WAT at the bottom. So pretty much what we were expecting, right? So we got our exported foo function, and you can see the function there, and all it does is pushes the constant 42 onto the stack. Pretty straightforward. But let's make it a little more advanced. Okay, let's return 42 times 2. Okay, that's a way better function. So I just compiled it, and the instructions at the bottom didn't change that much. So how come we don't see a multiply down there? Crazy, right? Okay, because the compiler optimizes these things for us. It understands that 42 times 2 is always going to return 84. And so it goes ahead and just changes the code, the output code at the bottom. This is a very simple example, but this is really important. You're going to want to use a higher level language that compiles to WebAssembly so that the compiler, which people have spent probably literally decades optimizing, can do this work for you. It's really powerful. It makes things really fast. So there are a lot of helper libraries out there too. Wasm-init is going to help you connect to your C++ modules. If you start compiling from C++, I guarantee you'll run into mscripting. It seems like everything pretty much is using mscripting. And it's really cool. It makes things really fast. There are some cool demos out there if you want to see some demos of WebAssembly. You can see Unity games that have been compiled to WebAssembly. I think there's even Unreal demos. It's very, very cool stuff, and it's amazing to see these things running super smooth in your browser, blow up zombies and stuff like that. That's what it's all about. So another one is Rust. Rust is like the coolest language ever, right? It has nothing to do with cars, but I love cars. Okay. So, what? Rusty's medicated bumper ointment? Nobody? Okay, anyway. So, yeah, Rust. You can compile Rust to WebAssembly. Really exciting. It's cool. And I also heard Nim. Nim can compile to WebAssembly. There's a lot of people targeting WebAssembly. And there's even this crop of new languages being born just to compile to WebAssembly. The one with the most steam seems to be this assembly script. So assembly script is cool because it's a subset of TypeScript. And so it's really easy to learn. It's a little bit stricter than TypeScript, but it's really easy to pick up. And just like wasm-fiddle, they have a website where you can just click a button. You can start compiling WebAssembly code. There's also TurboScript. It has a really cool mascot, so the Speedy Snail, which is fun, but pretty much the same thing as assembly script. ThinScript. I haven't really looked into ThinScript much, but these are all really, really cool little language that are being born. Okay, what's the point? The point is, WebAssembly is awesome. Woo! Okay, so this is so Batman is JavaScript, and Robin is WebAssembly, right? Yeah. I like that when he punches him, it says undefined. So it's really, really cool stuff. I'm really excited to see these things work together. I'm really excited to see what we build. WebAssembly it's amazing. I really think it's a big change coming to web development, coming to JavaScript. I mean, JavaScript is conquering the world out there. And WebAssembly is integrated with it. It's part of your JavaScript virtual machine. So it's riding on its back. You know, they're working together. JavaScript has a new superpower called WebAssembly, okay? Always bet on JavaScript, and I think always bet on WebAssembly right with that. And so these are my references. That's all I've got. Thanks for coming.